7 students so far.
Yeah, I'm opening up a chat window for the recording.
Great, thank you.
So I'm literally just listening in. I'm going to be working on other stuff on another computer, but I'll be here if questions come up or something.
Great, thank you.
Maybe I'll take the answers out of the file that you mentioned. It seems like a good time to do that.
Yeah, that would be necessary at some point.
But it would have been easier to grade, you have to admit.
Indeed.
Hey, so for the in-class section, is that going to start at 8, or is that going to start at, like, what time is that in-class section going to start at?
We're going to go over that, but I think on Thursday, during the lecture time, we are going to, and actually Dr. Cleveland is going to review some
Important things to know.
Yes, and then after that, we are going to use the lab time to go over the in-class section, but it may start earlier than 9:20. So you may want to be there from the beginning of the lecture.
All right.
Okay.
So Salvador, I will go over that. Actually, we're having 13 students logging in now. Hello and welcome everyone to this special review session. I'm going to start. Yes, but
yeah, Audrey's in it. Oh my god, I found out a lot about her. She was going to be a professional ballerina. She's
Kala.
Mute yourself.
Kala, we can all hear you.
Yeah, we can hear your conversation.
Yeah, and the story about the ballerina. Really?
Yeah. Yeah.
Looks like. So, I'm going to start recording this session on my end. Dr. Cleveland is also recording it, and it will be uploaded as soon as we can. Thank you very much for joining in. Thank you, Max. I thought since this is going to be more of an informal, non-mandatory session, I can be a little more informal in it. This background is from one of the games that I actually really like, the Borderlands. So we are going to talk a little about the general format of the exam, and then we're going to do a review from the very first lab session that we had together up until the last one that we covered last session. Since we do not have as many students, I will ask for your insight and cooperation from time to time. Feel free to ask questions. This entire session is all about you, and we are here to have you better prepared for the midterm exam and kind of reduce your stress levels on it. Dr. Cleveland has agreed to be in this meeting. As he explained earlier, he will be working on his stuff, but if you have any questions, he is looking at the chat box as well. So if you have questions from Dr. Cleveland, he is here on this beautiful Sunday evening. So let us begin by looking at the announcements that we have sent out about the exam, and let's see what we have already told you about the format. So what you know at this moment is that your midterm exam is going to have 2 parts, the in-class section and the take-home section. On Thursday, this week's Thursday, September 24th, we are going to have your in-class section during the lab session. And as Brandon has already asked, we are going to begin the lecture at 8 And Dr. Cleveland is going to do some reviews and talk about some important things that you need to know. And right after that, we will begin the in-class section. But I strongly recommend that you join the meeting right at 8 because there is a chance that we may start the in-class section earlier than 9:20. You will have 50 minutes to complete that part of your exam. It is mostly multiple choice questions, and also a few questions that will require you to work on codes and looking at Jupyter notebooks and stuff like that. You are allowed to have access to CodeCalc and Google, which I think gives you endless opportunities to use online resources in case you need them. And then your own notebook copies. So I hope, and I'm kind of positive that you have copies of your previous notebooks on your CodeCalc account. If you need time, you can go ahead and prepare them, organize them in a way that you have easier access to them during the exam and the time pressure of it. You are not allowed to consult with anyone, talk to each other, text each other, email each other, or any other types of communication. So we want you to work on this alone. As much as team efforts are appreciated in normal engineering projects, for this specific one, we require you to go solo. You are required to join the regular Zoom meeting link that you do every Thursday and every Tuesday. And we want you to activate your video while you are working on them. This is a question that I've received already, so I'm going to answer that. By this, we do not mean that we want you to record your screen. By this, we mean that we want you to have your webcam on so that we can see you, similar to what I can see right now with Brandon, with Max, Jack, Eric, Liana, Jaren, Kyle, and that's it. So we want to be able to see your faces as you're working on the exam. Another question that I received is that I do not have a webcam. It is okay if you do not have a webcam. You can use the same Zoom link and log in with your cell phones and use the front cam of your cell phones for this. So that is one way around it. And then the exam's password will be provided. So once you come to the meeting, we will give you the password and you will have access to your in-class section of the exam. Do you have any questions here?
Yeah, I got one.
Yeah, sure.
So if we have a second screen, do we need to turn that off during the exam?
I would say that we trust you with that. Dr. Cleveland?
Yeah, leave it on. There's no point.
Yeah. To be honest, at this point, I think we have a mutual understanding and respect for each other, both us on the instructor side and you on the student side. And I honestly don't think that you are going to have any trouble with this exam. If you know your lab and your notebooks, you're going to be, you're not going to need cheating. So that's one way of saying it. Do you have any other questions about the in-class section?
Yeah, so if you look at my webcam, it just started doing this, and then I just got moved into like an off-campus quarantine center, so I'm not allowed to leave and go get it fixed or anything.
I see.
And that's basically the only camera I have, so I was wondering what the solution
what I can see through your webcam is very similar to the vision of a newborn. So if you can log in with your cell phone, I think that will solve the issue. And I can see your haircut, so that's an improvement.
This just happened this morning, and so I don't know exactly what to do about it, but I can't do anything, so.
Do you think you can log in with your cell phone on that day?
Did you get jumped in your lens or something?
Test that real quick.
Yeah, you just need to click on the same link through your browser on your cell phone, and it will bring you here. And you can be in a meeting with both your computer, and your cell phone. There is no limit in Zoom.
Sounds good. Thank you.
Yep. Any other questions about the in-class section?
So the only form of cheating that we can do is, or what's considered cheating in this is just any sort of communication to anyone else on this?
Yes.
All right.
Yes. So you have access to Google, which means online resources.
Everything
you have
except
access
the help
to
of other people.
Yes, you
All right.
have access to CoCalc and your own notebooks. So those are the things that you have. We are only asking you not to communicate with anyone else, including your classmates.
All right. This second screen question confused me. Like,
No. You
Yeah.
you are allowed to have as many screens as you want.
Yeah, don't communicate. If you go to Stack Overflow looking for something, you can't. I can't enforce it, but don't type into the blog a question, and if somebody answers it, that would be cheating if we could detect it. Calling somebody would be cheating if we can detect it, and so on. So you're trying to test your own intellectual resources at doing these things. But using Google's fine. I mean, everything that you've seen in this class in the last 8 lessons pretty much taken from Google. That's why we try to keep the URLs preserved.
Audrey is asking how many questions are on the in-class section. I would say you can think about around 20, but you will have plenty of time. So when we say 50 minutes, that is going to be more than enough, if you are concerned about the time.
So will the in-class section be like structured similar to the quizzes?
In terms of formatting?
Like formatting. Like,
yes.
You have this piece of code, interpret what the output's supposed to be. You have this piece of code, debug it.
Or if I want to answer that in a more clear way, you will have to go through a link in your Blackboard, and very similar to your quizzes, you will select the answers to the questions, and then at the end you will click submit.
Okay.
Any other questions about the in-class section? Okay, so right when we are done with that lecture and lab session on Thursday, at noon, at 12, you are going to have access to your take-home section. You will have 24 hours to submit your answers, from noon to noon. So it's going to become available at noon on Thursday, and you will have until Friday, the next day at noon, to submit it. That will be your deadline. It is designed based on the materials that you've covered in class and lab. Again, the same 2 rules. You're allowed to use CoCalc, Google, and your notebook copies. You are not allowed to consult with anyone, either by telephone, by talking, by texting, by emailing. Any type of communication is forbidden. And you are required, this is extremely important, you are required to submit your notebook as notebooks or .ipynb files and PDFs. So usually with your lab assignments, we only require your PDF. For your exam, we want your PDF as well as your notebooks. And also, you are required to upload a CSV file that you will learn about when you see the questions. So eventually, at the end of the day, we want 3 files. A PDF of your notebook, a notebook format of your notebook, and a CSV file.
What do you mean notebook format?
You can save your notebook as a Jupyter notebook, and the format for that is .ipynb here. You cannot see my highlighting. One moment. Annotating. Okay. Can you see this red thingy on the screen?
Yes.
So you can save your notebooks in a file like that, and we want you to do that for your midterm exam.
Okay.
That's all we have on the take-home section. Let me know if you have any questions. Really? No questions?
So, I mean, I'm assuming just the take-home section is like, are we prompted with like exercises? Or is it like we have like a general overall problem and like it's up to us to design the code?
I would say a combination of both.
Okay.
So you will be given a bunch of questions, and you need to come up with your codes to answer them.
Right.
Depending on what the question asks, you will be required to utilize different things that you've learned through the past 8 or 9 weeks.
Okay.
So I would say the in-class section is relying more heavily on the theories.
Interpretation. Okay.
Yes. And the take-home section relies more on how well you can utilize your knowledge in terms of writing actual scripts and pieces of code.
Okay. And so how will the two be graded? Will it be just 50-50, 60-40?
Dr. Cleveland, I think this is a question that you can answer better. They're asking about the percentage of each part.
Take home versus in class?
Yes, sir.
Let me check the email from Friday. I think it's 50-50.
I believe that was the latest decision.
So they're equally weighted. It's to your benefit to do as well as you can on both.
Right.
Any other questions? Will this video be saved? Yes. This is being recorded both on my side and Dr. Cleveland's side, and it will be uploaded as soon as we can.
I have a question.
Yeah, go ahead.
Okay, so when you say that we're given 24 hours, does that mean that it's kind of like the quizzes where we can just pop in and then save in at our leisure, or do we have to, in this 24 hours, we're given a time period to do the exam?
We need you to submit your files before the next day's noon. So if you want, you can submit it in 1 hour. I actually kind of doubt it, but you have the options of submitting it within a 24-hour window.
So it'll feel like a laboratory notebook that you're working in. So it's just like that. So when you get it all done, or you're getting close to the end of that 24-hour window, you just want to upload everything and submit it.
Any other questions about the take-home section?
It won't send you reminders, so don't screw that up, because that's half the exam.
Okay. So if we are good about the general format of the exam, I want us to go and start our review in the CoCalc. So what I have in front of me is the very first lab notebook that we worked on, known by Laboratory 1, also known as Laboratory 0.
Because we can't
the
count.
One. Yeah. So, do you all have this in front of you?
Okay, there it is.
Because I generally recommend that you follow me as I go through it. But if you don't want to do anything on your computers and you just want to see my screen, that is also fine. So, the very first notebook doesn't really have much meat on it, because we were just trying to kind of make you familiar with the environment. We worked on a few exercises in the first one. we asked you to go ahead and run a link for a Python online compiler, do a very basic template of hello world in there, and then do a screenshot. Then in exercise 2, we asked you to open codecalc.com, set up your account, and get another screenshot of that. In exercise 3, you actually ran your first line of code with print hello world as a string, and then we asked you to go and change that hello world to another string and print that out. And then for exercise 4, it was about how you can embed an image within your notebook, and you did that. So, do you have any questions about this notebook? No? Okay, cool. Then we, for the next, was that a question for me?
Someone's watching TV, it sounds like.
Oh, okay. So, then for the next session, we actually started getting a little more things to do. In lab 2, we talked about different kinds of variables, different kinds of operations, different kinds of objects. Something very, very important that I want to emphasize on, and I will probably repeat that a few more times this session. If you know the material in your notebooks, and if you know your way around your notebooks, there is a very low chance that you will not ace this midterm. But you need to know your stuff. Nothing outside what we covered. But everything in there, you need to be on top of it. So everything that we have explained here in the explanation parts, every example, every exercise, they are all equally important. And you need to make sure that you understand them. So if, as we are going through them right now, if you have any questions, ask. If you are studying for your midterm and if you have questions, come to my office hours this week, or just email me with your questions. Because that is the vital material that you need to know in order to ace this midterm. As I said, we talked about different operators. We had a little table here with all the symbols, all the meaning of those symbols, and then examples of them. We talked about simple operations. We talked about arithmetic assignment operators. We talked about data types, integers, floats, strings, how you can convert an integer into a float, how you can convert a float into an integer. These were the pretty initial or basic steps that we covered in this lab. Here, about changing types using the int function, the float function, the string function, what they do. Then we talked about simple string manipulation, and that was your first exercise. So we gave you some simple print commands and asked you about the difference between printing 3 plus 2 and printing quotation 3 plus 2. And remembering the notebooks that you submitted and I was grading them, I think almost all of you got this right. The fact that when you put a quotation and you define something as a string, everything in that string will be printed. But if you do not use a quotation mark, that will be interpreted as an actual operation, and the result of that operation, the output of that operation, will be printed. And then printing an object as an object, or printing a string with the same name, and what are the differences. Then for exercise 2, we ask you to create a simple script that illustrates the following types of variables. So we asked you to create an integer, create a float, creating a string, and create a Boolean object. So pop-up question. what is a Boolean object?
It's a true or false statement.
Exactly. So it has a binary outcome. It's either true or false. Then, for exercise 3, we ask you to calculate the expressions below by hand and then go and calculate them in Python and see whether they're any different or not. The thing that you need to know about this one is that which operation has priority over the other operations, and that's the only thing about it.
Did it? I should probably just go back and answer my own question, but did it follow PANDAS or did it just go left to right?
It actually follows the priority of operations. So, for example, if you look at this that I've highlighted here,
it's going to multiply before it's going to add.
Exactly.
Okay.
Exactly. Then for exercise 4, this was actually the first time that you used the input function and asked for users' input in a script, something that later on you used multiple times in your other codes. Here, for example, you were asking for a float, and then because your user could have entered an integer or a float and you wanted a float anyway, you used the float function to convert that number to a float, and similarly for float 2, and then you compared float 1 and float 2, and the output of this will be a Boolean object as true or false. Okay, then in exercise 5, we asked you to play around with a string, and this is basically an indexing practice. We gave you computational thinking as a string, and then we wanted you to print out one slice of that string that starts at position 0 and ends in position 5. And that's what we did at the end of lab 2. Do you have any questions about this lab? I hear no questions, so once again, be sure that you have read and understood every single piece of information you have in these notebooks, and not only the exercises. All the notebooks, all different parts of the notebooks are equally important. For lab 3, who is watching TV? Can you please mute? If you can hear me and you're watching TV, can you please mute your mic? So, for lab 3, we talked about data structures and conditional execution. So we talked about lists, we talked about tuples, we talked about dictionaries, and here is a good opportunity for me to ask another pop-up. Feel free to unmute and answer my question. What is the difference between a tuple and a list?
A tuple you can't append, but a list you can.
Yeah, that's pretty much it. Or as they say, a tuple is immutable and you can't really change what's in it. Can someone else tell me what is the relationship between a dictionary and a list? Getting tricky, huh?
A dictionary is pretty much a list that has different keys, right? So then the key is associated with like a pocket of data or like pockets of data.
Very good. Thank you very much. So a dictionary can be considered as a special list that comes with 2 important elements: a bunch of keys and a bunch of data that are associated with the keys. So let me find that. Okay, so for example, here we are creating a dictionary. The name of that is my pet's name and mass. And then you have your keys, Dusty, Aspen, and Marry Me. And then you have numbers or data associated with each key that makes the structure of your dictionary. Pay attention to the details. These are very simple stuff, but you need to be completely comfortable with them. Pay attention to the details. For example, how do we define a list? How do we define a tuple? How do we define a dictionary? These are pretty basic stuff that you need to know. Then let me see.
So an item, like a key in the dictionary, is basically a variable. Like it's like a dictionary is basically just a group of variables, and every time we call onto that variable, it gives us the value that's assigned to it, right?
Yes, I'm not really sure what you mean by variable.
So like Dusty, we could say that like that's variable X or variable Dusty, and the value that's assigned to it is 7.8.
Yes, I would go ahead.
Just to refer to them to keys.
Yes, you can refer to them as objects. So, for example, Dusty here is a string that is our first key in this dictionary. Mm-hmm. The second key is Aspen. The third key is Marry Me. And then the data associated with Dusty is a number that is 7.8.
Okay.
Can the data associated with a key be a list?
Yes.
Yes. Because you have already dealt with something like this, which was a nested dictionary.
Yeah.
And that was your exercise 3 that we had asked you to go in, and at the end, drag this hello string out. So your dictionary can be nested, can be different layers of lists or dictionaries or tuples. Let me see what we had for exercise 1 and 2. In the first one, we simply asked you to create a list and then slice that and then get the length and sum of the elements. These are things that you know like that. So when we have a list, we can easily sum all those numbers in that array or list up. We can subtract them, we can multiply them, we can divide them, we can get their length. How big is our list? How we can slice our lists and create sublists from them. These are the things that you have done in your exercises 1 and 2. Let me go on and see what else we had here. We talked about dictionaries. Each one of these has explanations and text associated with them. Make sure that you read them. And then we went on and talked about conditional executions. So different types of statements that will return true or false values. Is A bigger than? Is A equal to B? Is A less than or equal to B? These are all different kinds of comparisons that we can do in Python. And we worked on different examples with our X and Y here. And then we talked about logical operators like and or. You have already used them and realized how important they can be when you are defining for loops on multiple criteria equations. So, for example, I will touch on that as we move on. But in your lab 4, you were asked to do a for loop, and then if the value is between 1 and 0, do this. If it's between 1 and 2, do this. And you use that by using and or statements. The important thing to know about and or statements is that for the and statement to be true, you need A and B to be true at the same time. But with the or statement, if only one of them is correct, the outcome will be true. Then we talked about if statements, how we can control our code or the flow of our code by using different conditions. So for example, here you can see that the syntax is basically saying if condition 1 is met, then do task A. If condition 2 is met, then do task B. If condition 3 is met, then do C. And else, which means if it's not condition 1, if it's not condition 2, if it's not condition 3, then do this for the rest of the situations. This is very, very important. You need to know how to correctly run and set up and design a block of if statements. We had examples on it. You have worked on different exercises with them. On the same line, we talked about inline if statements. So rather than writing them like a block of code, we can write them in one line and say, okay, do task A if this condition is true, else, or if that condition is not true, then do task B. The logic behind it is exactly the same, but this one is simply a one-liner, not a block of code. Then we went ahead and you worked on one example which you would feed in 3 grades, and then the code would go in, calculate the average score, and then compare that average score with number 5. If it was greater than or equal 5, then it would say passed, else it would say failed. And then you worked on an exercise on your own, which kind of followed the same logic, but instead you would ask for 2 inputs. One of them was the number of classes held, and the other one was number of classes attended. It would do a simple calculation, compute the ratio, and based on that, if it was above 75%, it would say allowed. If under 75%, it would say not allowed. So this would be a very simple illustration of why and how we can use if statements. Then on exercise 6, which I believe you should remember clearly, it was about the Robocop, and you need to go in and modify the code so that instead of the original conditions that was programmed into the machine, it would do what you want. And that was basically you coming to the end of the script and changing 2 numbers to get the new conditions that you want. That was your lab 3. So in this one, we talked about different types of lists, very important. And then we talked about if statements and conditional statements, also very important. It can be divided into 2 categories. Do you have any questions about lab 3?
I had a question about the if, elif, else. Do you need to have print statements for each if print something, elif print something? Like, do you need a print statement for each one?
No. Actually, that is not a necessary thing to have. The print something is basically a task that you are asking your code to do in case of a specific condition being met. So no, you don't have to have it there. It really depends on what you want your code to do.
Okay.
Let me see. I believe we should have... Now, unfortunately, I can see why it confused you, because all the examples that we have here do have the prints included in them, but that is not a necessary part of if statements or if blocks. So, do we have any other questions about lab 3? That was a very good one. All good? Nothing in the chat box. Okay, so in lab 4, we started to talk about more advanced program flow controls and different kinds of loops. We generally have two different classes of loops. We have count-controlled repetition, and we have Sentinel-controlled repetition. The first one basically means that before designing that loop, you know how many repetitions you need. So you want your loop to go for a certain number of rounds, 5, 10, 20, 500, whatever that number is. It is defined. You know that. That is count-controlled repetition. The other one, the Sentinel control, you don't really know how many loops you will have. What you do know is that until a certain condition is met, you want the loop to go on. Usually, this is not a correct statement, but usually people associate count-controlled repetition with for loops and Sentinel-controlled repetition with while loops. Do not let that sink into your brains, because we can have for loops and while loops as count-controlled or as Sentinel-controlled. It is not a rule, but it's just something that many people say. So what you need to know is that with count-controlled, you know how many rounds, how many repetitions you need. With the second one, you don't really know. So then we started talking about the structure of a for loop, which is in the very basic like this. So for A, which in this case A is your counter, in many examples that you've worked on, we call that I. In iterable, usually we use the range function here. In a sequence of numbers that it's going to start counting, we want to do a certain task. And again, Audrey, this doesn't have to be print. This can be any action or any task that you want your code to do. A very simple example of it, then we talk about the range function, the syntax of the range function, which basically asks you, where do you want to begin your sequence? Where do you want to end your sequence? And how big do you want your increments or your steps to be? Pop-up question. What is a huge limit with the range function that you have already realized?
Can't be a float.
Thank you very much. Sorry about that. So the range function does not work with floats. And that is something that we have learned how to get around. We go with a counter and then an actual object that we are interested in. When we get to the examples and exercises, we can talk about that if you want. Then basically in this example, we are using the for loop to go through a list. Something that, again, you have used, for example, when you wanted to create a plot with a certain list of x values. First, you have your list. Here, it's my pets, 3 objects in it, Dusty, Aspen, Marry Me. Then you create a sequence of numbers that starts at 0, goes until 3 by steps of 1. So basically 0, 1, 2. And then for I in that range, you want to print the ith element of your my pets list. So when I is 0, what will be printed?
Dusty.
Dusty. When I is 1, what will be printed?
Aspen.
When I is 2, what will be printed?
Miriam.
When I is 3, what will be printed?
Nothing.
Because I will never get to 3, because of the way that you have defined your range function. Does that make sense? Cool. Then your exercise 1 asked you to print out all the leap years in the 20th century from 1904 until 1999. And we basically asked for a range of numbers that start at 1904, go until 2000 by steps of 4. And it would print us the list that we want. Then for the Sentinel control repetition, as I said, when loop control is based on the value of what we are processing, Sentinel control repetition is used. Sentinel control repetition is also called indefinite repetition because it is not known in advance how many times the loop will be executed. And just to emphasize on the point I told you earlier, we can use both for and while loops for Sentinel control repetition. But while loops is more common. So do not believe if other people tell you otherwise. There is no exclusivity, I'm not even sure if that's a word, for loops and count controlled and while and Sentinel controlled. So the way that the while loop works is pretty much like this. So you feed in a condition that is important for you, and you ask your Python to execute one or multiple tasks as long as that condition is true. Then we worked on some examples. We talked about nested repetition, which basically means that you have, for example, for loops that have while loops inside it. Or you have for loops that have for loops that have for loops inside them. Similar to the nested dictionary, the term nested is used in programming whenever you have one structure within another structure. In this case, loops. Then we talked about the break function to exit out of a loop. And we actually showed you what does the break function do. Here in this example, we are saying that we want our initial value for j to be 0, and then we want our I to change in a range of 0 until 5 by a steps of 1. And pop-up question, what does this mean?
J equals j plus 2.
Yeah.
Go again, Eric.
You'll add 2 to every variation. Or
Exactly. So at every step that your I counts, you want your j to be equal to the previous amount of j plus 2. Okay? So when I is equal to 0, what is the first value of j?
0 or 2.
It's 2, because the initial value was 0. Here it takes 0 and adds 2 to it, and it becomes 2. Then when I is equal to 1, what is the value of j?
4.
4, because just like that, it adds another 2 to it. What if when I is equal to 2?
It equals 6, but then
It will
breaks.
Exactly. Why? Because here we have added another condition. We've said, okay, if j is equal to 6, that is a condition. If that condition is met, do this task, and that task is break. And by running that, it will simply end the loop. Okay? Then what did we talk about? Oh, something important. Here in this example, this is the first time that you learned how to create a table by using the specific formatting. Later, we also learned how to create a table by using an external library called Pretty Table. But this one is a very valuable thing to know, that by feeding or designing a specific format, you can have a table-like a structure in the output. then for exercise 2, okay, this is the one that I was referring to. You were asked to create a Python script that does this. So basically, for any input that you give, for any numeric input that you give, it would see if x is between 0 and 1, then the value of y will be equal to x. If x is between 1 and 2, then y will be equal to x to the power of 2. And then for any other conditions, y will be equal to x plus 2. And we did that by using an if block. So if x is greater than or equals 0 and x is less than 1, that will be it. So, for example, Audrey, again, to answer your previous question, we are saying that if this condition is met, do two things. One of them is this one. Put y equal to x. And the second task is to print that. So we could easily just go ahead and remove this, and we would still have a loop because we have a task of y equal to x. And then for exercise 3, you were asked to use the same rules and complete a table like this. You did that pretty easy. You first created a for loop, a count-controlled for loop, and you asked for your x to be in a range of 0 until 6 by steps of 1. The reason for that is that your x values are already given to you. 0, 1, 2, 3, 4, 5. Then you applied the same 3 rules, and at the end of it, you printed the table that you had created with your pretty table function from the external library. And that would give you an output like this, or you could do that with your handwritten tables, similar output. For exercise 4, you were asked to do the same thing, but for x from 0 until 6 with increments of 0.5. And this is where the limit of the range function comes out, which Brandon has already told us. The range function by its own, on its own, do not really support float numbers. It only works with integers. And when you need to have increments of less than 1, you need to come up with a trick. What trick is that? In the solution, what I did, for example, was that I said, okay, I want to go from 0 to 5. If I want to go by steps of 1, how many steps will that be?
Five.
Come again?
5.
5. If I want to go with the steps of 0.5, how many steps will that be?
You can't even do steps to 0.5 unless you do the hack, and then you can do 10 steps.
That will be 10 steps. At this point, when I'm asking this question, I don't really care about the range function. I just want to ask something from a calculation that you're doing in your mind.
Okay.
If I want to go with the steps of 0.25, how many steps will that be?
10.
We want to go from 0 to 5
20.
with the steps of 0.25. That will be 20 steps. Okay? This calculation that you're doing in your brain is an important part of this trick. So, since here I want to go with the steps of 0.5, I want to go with 10 steps. So, in my range function, I set it up in a way that it does 10 counts for me, from 0 to 11 with the steps of 1. What is the initial value of x that I want? We already know that. That's 0. So we set our x to 0. Then we go and ask our code to add the amount of increment that we have in mind, in this case 0.5, add that to our previous value of x at every iteration. So when I is 0, my x is
0.
It starts at 0, but it will be added to 0.5.
When I is 0, then x
Yes.
is going to be at 0.5.
Then what about I is equal to 1?
When I is equal to 1, x is going to be equal to 1.
Exactly. So for every time that I goes up, we will have 0.5 added to our previous x. And then based on what that x is, we use these conditions to calculate the value of y, and we will get what we want. So this here is all you need to know about the trick of going with increments less than 1 or increments as floats. So let me ask you a question, and okay, whoever they want, they can answer. If I want to go with a steps of 2.5 from 0 to 15, how many steps will I need?
60? No, 30.
Listen to the question again.
2.5.
I want to go from 0 to 15 with increments of size 2.5.
Oh, 2.5, 7 steps.
7 steps. Start counting for me. So I'm at 0. Step 1 will take me to
2.5.
2.5. Step 2,
5.
5. Step 3,
7.5.
Step 4,
11. I think. No.
10.
10. I'm really bad.
Step 5,
12.5.
Step 6,
15.
there you go. So if you want to build that in your code, you know that you're starting at 0, so your x will be 0. Mm-hmm. Then how many steps do you want? You just counted that. You need 6 steps. So you set your I in the range of 0 to 7 to 1.
Right. Okay.
And then at every step, your x will be plus equal 2.5.
Okay.
So all the students in the meeting, did you get that?
So I plugged in that. So I had a different code than what you had, but when I plugged in the x plus equals 0.5, it was going by increments of 1, but there was just a 0.5 in it.
Can you paste your script in the chat box? I like the background music, by the way. Okay. Let's have a look at this. So, what is happening? We are saying that I want the initial value of x to be 0, then I want x to change in a range of 0 to 11 to 1. So we want it to change for 10 steps. At each step, we want to add 0.5. Let's run this. So what is the issue?
Well, doesn't it need, if it's going by steps of 5, doesn't 1 need to be a value? And 2 and 3 and all that?
You are asking it to go up by steps of 0.5. And that's exactly what, I see what you're saying. Okay.
Because whenever, my original one is that it needs to do it x times 0.5, and that does all the steps.
Now this one should also work. So for me, it is going by steps of 0.5. Let's see what is happening.
Oh, because you're using the iterable x both as an iterable and as a counting variable.
Yes, thank you very much. So if you notice in my script, I'm using I as my counter, and then x is my object that I'm using. So if you change this to I or to anything else, so this code was from Max, so I'm going to call this M. You need your counter to be a different value than your x. If I run this now, you will see that it is going up by steps of 0.5. Does it make more sense now?
Yes, so basically for every range, I should just keep it as I, so I keep my variables. I don't make some of variables.
If the increments that you are working with are already integers, there is no issues with using x or defining x with a sequence using the range function, and then just go ahead with that. But this trick that we are doing here is for when we need to go with a float and the range function does not support floats. And for this one, you need your x and your counter to be different objects.
Okay, thank you.
Actually, if I go up, for example, in this one, in exercise 3, we wanted our x to change from 0 to 5, and with the steps of 1. So everything was integers. So we actually used this line to define our x within a sequence of numbers that starts at 0, goes until 6 with the steps of 1. And then we used that as our x object. But if you are using floats, similar to exercise 4, then you need to go with this trick. Does it make sense?
Yes.
Great. Do we have any other questions about this specific way of using the range function? And Dr. Cleveland has already put something in the chat box. Thank you. If you want to learn more about the range function.
I'm testing it to see if it actually works first. And then I want to do the type.
Yes, go ahead.
What is the purpose for the conditions such as x is greater than or equal to 0 and x is less than 1? Like, with the if, else, like, what is the purpose of this?
So, looking at exercise 2.
Okay, so are they all the exercises, those are all related to that?
Yes.
Okay, that makes sense.
Yeah, so for exercise 2, we simply designed an if block to apply these conditions on any inputs that the user may put. For exercise 3, we said that, okay, assuming that these x values are given to you, we want you to go ahead and fill this table. But again, with the same rules and conditions. For exercise 4, again, we said, okay, if these x values are given to you, what will happen? So 4, 3, and 2 are kind of coming on top of each other.
Okay, thank you.
Yeah. So, let us move on. After this, we talked about the continuous statement, kind of working the opposite of the break command. The continue instruction skips the block of code after it is executed for that iteration. So in this example, in this example, we are saying, okay, if our initial value for j is equal to 0, Then for I in range of 0 until 4 with the steps of 1, we want our j to be equal to 2 plus the previous value of j. And that's what we want to happen. But if j is equal to 6, instead of breaking the loop, we want to continue to print this. So continue and break are kind of similar and kind of opposite. What you need to know is that with the break, when that condition is met, break will cut the loop and go on. Continue will kind of skip the next block of code and get to the beginning of the next line. These are the main differences between break and continue. Again, if you follow the explanations for each statement, you will know more about them, and I definitely strongly recommend that you read the entire bodies of your notebooks. Then we talked about something extremely important, the try-except structure, which is actually a very cool feature in Python. And you use this as an error trapping method. And by this, you basically say that this is what I want to do under try. And then if for some reason there was an error, do this, which you define under except. So the simple syntax is here: try, column, do something. If that gave you an error, then jump to except and do something else. So we did an example of two sets of numbers that we wanted to divide by each other, and then at some point we would face a 0, and since you cannot divide a number by 0, it would give you an error. And we used the try except structure to print this in case of the error. And whenever you run this, it will start dividing 12 by different values of y. And as long as y is not equal to 0, right up until here, it will calculate the value of x over y for you. But right in the time that y gets equal to 0, it will give you an error because you cannot divide a value by 0. And then instead of jumping out of the script and saying that I can't run this because of this error, it will move to the except part and print error divide by 0. And then it will keep going. So this is an extremely efficient way for cases that you kind of expect an error that might happen. So you as the programmer foresee that, okay, this may happen. And you don't want your code to die. So you kind of plant this to dodge bullets that you may foresee. This is not a guarantee that your code will never scream out an error to you. But this is only a way for you to dodge the bullets that you kind of see may come your way.
So for except, when you put except, that means that if there's ever an error.
If there is ever an error in the try part, it will jump to the except part.
Okay.
So I find this very, very useful and helpful. So try, do something, do whatever you want to do. And then except, basically, do something else if the do something returns an error.
Got it.
So, usually the main body of your code and the main purpose of what you want to do will be under try. And for except, you are basically defining tasks to be done in case of potential errors coming up. So, let us move on and see what else we had. Then we had the exercise 5, which asked you to modify your exercise 3 script to prompt the user for 3 inputs, a starting value for x, an increment to change x by, and then how many steps to take, your script should produce a table like this, but the increments can be different from 1 as above. Include error trapping that takes any numeric input for x as its increment and forces it into a float, takes any numeric input for number of steps and forces it into an integer, takes any non-numeric input, issues a message that the input needs to be numeric, and makes the user try again. This is an extremely important exercise, and unfortunately, many of you lost some points on this. Do I have anyone in this meeting who has a question about this exercise? No, really?
If you have time to like walk through it again, that would be nice, because I kind of like, I remember struggling with this one in particular. I got it eventually, but it just took me a while to figure out.
Sure. We have at least until 7, so the first questions will be answered first. Here is something that I wrote. Very similar to what you will deal with during your midterm exam. There is no specific or single way that we say, okay, this is correct and anything else is wrong. As long as your code does what it is supposed to do and you have written it in any way that you want, that will be accepted. So what I did is that first I asked for my user input and I asked them to enter the starting value for x. Then I forced that value to be a float. Then enter the increment for x, and I forced that value to be a float. Then I asked for how many steps they want for x, and then I forced that into an integer. So these 2 tasks were done right away at the beginning. Take any numeric input for x or its increment, force it into float, take any numeric input for number of steps, and then force it into an integer. These 2 are done right here. Something very important that you need to notice is that the syntax for range is quite different from the 3 questions that you have asked so far. Can you tell me what is the syntax for the range function?
We enter it ourselves.
Yes, so you go range, open parentheses, 3 values. What are those 3 values?
Your starting point, like before you, like you don't get to that point, but the point before that, and then your rate.
Yes, so basically where you want to start, until what point you want to go, and how big you want your steps to be. The questions that I asked so far is not exactly like that. So I'm asking, where do you want to begin? That will be my starting point. And then how big I want my steps to be. So that is kind of the third thing that you usually feed to your range function. And then I ask how many steps you want to go. That is not where I want to end. That is how many steps I want to take. This is a very important difference that you need to notice. So I go and I multiply my step by my number of steps to compute the endpoint of the range by multiplying number of steps and their size. That is not really an important step. So if you don't have that in your code, you will not miss anything. The important part starts from here. So I create an empty table with x and y as headings. Then I say I want the initial value of my x to be equal to what my user told me as my first input minus the size of my step. So I want to actually start 1 step behind my initial value. The reason for that is here. So I'm defining a counter that starts counting from 0, goes until the number of steps that, again, my user has given me, by steps of 1. Pay attention that this I is simply a counter, similar to the trick that we already covered. So at the first step, when my I is equal to 0, I want my x to be this value that I've already defined as my initial value, plus the size of my step. So if the user had asked me to go by steps of 2, this will be my initial value for x plus 2. If they want me to go by steps of 0.5, this will be my initial value for x plus 0.5. Whatever the user wants. Then it will go and apply these conditions to see how it should calculate the value of y. Whether it's going to be equal to x, whether it's going to be to the second power of x, or equal to x plus 2. And then it will print the table t at the end. But if you notice, I am using the try except structure. The reason for this is that if my user, when I ask for the initial value of x, or the size of the steps, or the number of steps, instead of giving me a numeric, if they give me a string, a word, or a sentence, if I do not go with the try except structure, that will break my code and it will just produce an error. But by using this, I'm saying, okay, if you get an error in this try section, jump to my except part and simply print the input needs to be numeric, please try again. So this is the third thing that I was asked to. Takes any non-numeric input, issues a message that the input needs to be numeric, and makes the user try again. So it is very important for every code that you will write in the future, and also for your exam, that you test your code with different values. In this case, you are asked to test these 3 cases. So Fred for the first value, 0.5 for the next value, and 7 for the third value. So if I run this code, the first question is enter the starting value for x. So if I say Fred, what do you think will happen?
It'll give you the except the input needs to be numeric. Exactly.
The input needs to be numeric, let's try again. So if I run this again, the second case wants me to start at 0, go by steps of 0.5 and for 7 steps. If I go with 0 and steps of 0.5 and for 7 steps, this is what will happen. Does that make sense? So this is a very good and important exercise because you are asking for user input, you're doing error trapping, you are creating a sequence with float steps, and you're doing all of them in a meaningful way. Do you have any more questions about this exercise? And Keith, thank you very much. I just saw what you said in the chat box, and that is absolutely correct. So, as I can see or hear no questions, I assume that you are good with Lab 4. We are going to proceed to Lab 5, which was about functions. So, if I say that we have 3 groups of functions, can you name them for me? Go ahead, don't be afraid. Built out. Thank you. Home built. and external. Thank you very much, Dr. Cleveland. If only they could ask these questions during the midterm. So, generally, you can categorize your functions in Python in 3 branches. The first ones are the built-in functions in Python, or we sometimes refer to them as primitive Python, because you can just open a Jupyter notebook and run them and they will work. So functions such as everything that you see in this list: print, input, I don't know, dict, int, float. These are all built-in functions. So they're already there when you're working with your Python, your primitive Python. Then we have functions from external libraries, similar to what we covered this week on Numpy, on Pandas, on Math, on Pretty Table. So these functions will not run if you just call them. You need to first go and import their library or their toolbox, and from that you can use those functions. These are called external functions. Then the third group are user-built or home-built, as Dr. Cleveland has mentioned. So these functions are the ones that you make. They're custom-made. You can name them, you can define them, and you can run them. If I write user-built function, you will probably have no idea what it does until I tell you, because that is something that I have built in my code by my own standards. I have named it as I want it. I have defined the inputs, and I have set up the function in a way that it does what I want to those inputs. So that is completely custom built or custom made. So these are the 3 functions that you need to, 3 types of functions that you need to know about. Then we had examples of each one, both as examples and as exercises. Then, for example, here we were asked to create this function as a user-built function. So, for example, my code for that goes in and from the math library imports the exp function. And again, from the math library exports the cosine function. And here I'm defining my function. I'm naming it Golem, my column. And I want Golem to be run on one input. And based on that input x, it is computing an object that is called precious, and that will be equal to the exponential of x minus 10 multiplied by cosine of x minus 100. Where did I get this? From the question here. And then at the end, it will return the calculated values stored in the precious object. Something important that you already know about, if you read this part, is that we call precious a local variable. What do I mean by a local variable?
And variable can only be called within the function.
Thank you very much, Leanna. Yes, a local variable is defined within a function. Outside that function, that variable is not defined. For example, precious here in my Golem function, that is a local variable. What do I have in opposite of a local variable?
Global.
And what is that?
Like, what is a global variable?
I
mean, your global variable right now would be whatever Golem is defined as, so x, right, or no?
That was good. Generally, the global variable is a variable that is defined outside a function.
Okay.
And it has a meaning and a content outside a variable. So, thank you very much, Max. Yes, that is also correct. So I have a question, another question actually. Can I use a global variable inside a function?
Yeah.
Yes.
Yes. Can I use a local variable outside a function?
No.
Very good. Very good. Very good. I'm proud of you. So, that's what I had for this example. Then, again, read the entire body of your notebooks as you are preparing for your midterm. Here you learn something very important about creating a function in an external file. So we use the Nico function. I can't see if Nico is still looking at us through the screen or not, but we use the Nico function to create a separate file in our working directory, and then we could go and call that from that file. So this is a different way for dealing with user-built functions. The output will be identical, but for many cases, you just want one separate text file with all your functions in it, and then you can call those functions as you need them in your scripts.
Oh,
So,
will we have to download anything for the midterm?
what do you mean?
Like, will we have to download like any IPYNB files, any Excel files, anything like that?
No.
Okay.
I will tell you what I know, and then Dr. Cleveland can say if I am correct or not. You will basically be given the link to your list of questions.
Okay.
And then what we want from you is a notebook as a .ipynb file,
Right.
a PDF of that notebook, and the CSV file that you will learn more about when you see the questions.
Yeah.
Okay, cool.
Actually, it's more prescribed than that. You'll be given a link to a notebook, and then you
Oh, okay.
fill out the notebook just like you do a lab.
Okay, sweet.
Thank you. So, let us move forward. Once we talked about different, yeah.
Sorry, one more question. For the so we're going to be sent a link for the lab. Is the lab going to be the in-class part of our exam, or is it going to be the outside part of our exam?
The in-class will be provided to you within Blackboard.
So it's going to be a quiz, or it's going to be a lab?
A quiz.
Okay.
Yeah. On the Blackboard, very similar to how you access your usual weekly quizzes, this will be provided with a link. You will click on that in your Blackboard, and you will see all the questions. You can answer them, and you will submit your answers at the end.
Okay, perfect. Thank you.
Yeah. So, once we talked about different functions and how we can define them, how we can call them, how we can use them, we went to graphics, plots, the cool parts that are easier on your eyes rather than just a bunch of numbers and tables. So we used the matplotlib library to create plots. The general formatting of a plot is like this. So plt or matplotlib library dot plot, that is the function that you want. And how it works is that it needs two lists. Repeat number 1. It needs two lists. Repeat number 2. It needs two lists. So if you just give it points, it will just draw 1 point for you, and that will not be a plot or a curve or a line. That is very important to remember. You need a list of your x values and a list of your y values, and then it will go and connect those points, and that will be your curve. So, the first list that you will feed to your plot function is your list of y values, Then the second list will be the list of your y values. Then you will define the color of your curve. Here we have a green one. Then you will define the marker for your curve. Here we are going with the O, and that's why you see different circles. You can go with a lot of different things. So if I go with S and I run this, you will see that instead of circles I have squares. Or if I go with star sign, you will see that I will have little stars instead of my markers. So there are different ways that you can get creative with this. But just pay attention to the formatting right now. Color, marker, line style. If you go with solid, you will see a solid line connecting all these points together. If you go with dash dot, for example, you will see that it will create something like this. So these are how you generally format your plot. And then you use the plt.title function to add a strings to the top of your plot as a title. Then the y label to add the label to your y-axis, the x label to add the label to your x-axis, and the plt.show to show the plot at the end of it. That is if you want to go directly to the matplotlib library, import it, and create a plot. Then we created a function for plotting. We called, this is a user-built function again. We called that function plot-align. That is a name that Dr. Cleveland decided to go with. You can go with any name that you want. Then we are defining that function in a way that it will expect 5 inputs. A list as the first input, another list as the second input, a string X, a string Y, and a string title. And again, you need to remember that when you are defining the function or you're defining a class later on, the order of these things are extremely important. Why? Because when you are defining this, let's see what is happening. We say, okay, every time that we run this function, you should go ahead and import this external library for us. Then you need to call the plot function from that external library, and you are going to plot list 1 and list 2. So, as I told you, and now I want to ask you, what is list 1?
The x values.
It is a list of your x values. Now imagine that when you were running this function, instead of feeding your x values as the first input, you feed it as the second input. What do you think will happen?
The x values become the y values.
Yes, and that will be chaos, that will be a mess, and that will cause you to lose points. And you don't want that to happen. So you need to be careful with the order that you're defining your function and use the same order when you're running your function. This is a user-built function, so you are in control. You can go with whatever order that you want. You can define this function in a way that it will ask for the plot title first. It doesn't really matter. What matters is that you are consistent in order. The same order that is defined will be used to run the function. So, then we are saying that we want our plot to be green, we want this marker to use, we want this line of style to go on, and from this point on, whenever I run the plot-align function, I will get a green line with circles as markers and a solid line as connectors. That is because I am defining my function in that way. If you want it to be pink, if you want it to be squares, if you want it to be dash dots, this is where you define your preferences. And then I'm saying that the 5th input should go into my title. The 4th input should go to my y label, and the third input should go to my x label. And then at the end, I want to show my plot. So this is what is happening when I'm defining my plot line function. And then I can go and say, okay, my x list is this, my y list is this. Now I'm calling my plot a line function. As the first input, I'm feeding my years object. As the second input, I'm feeding my GDP object. And then I'm going with year as my title for the x-axis. Billions of dollars as the title of my y-axis. And then nominal GDP as the title of my plot. This order should be identical to this order. How many times have I repeated that?
Like 100 times.
Yeah, and you would think that's enough.
It's not.
So, for the last time, make sure that you are defining your function in the way that you want, and then you are running it in the same way. That is the whole point to creating a user-built function. So, then, as an example, I showed you how to define another plotting-related function. I called it line, and that would go ahead and ask for 4 values, 2 values for x, 2 values for y, and then it would plot a straight line between the points that you have defined. What is happening inside it is very similar to what you have already seen. And then we went ahead and we created the hopeless romantics curve based on 2 equations that we have, and the t arranging in between 2 values that we were given by the question. I would not emphasize on this as much as the rest of the examples and exercises that you have in this notebook, because this was something that I thought looks cool. This could be considered a little too complex. So make sure that you read this script and you understand what is happening in it. If you don't, ask me a question. But the rest of the examples, especially this one and the previous ones, are more accurate in terms of what you may see in the midterm exam. So in this one, you are asked to use the plotline function to plot y equal to x to the power of 2 for x ranging from 0 to 9 in inclusive sequence. So what are we doing? We are creating 2 empty lists. Why?
So we can fill them in.
So we can append it to them?
So we can append them.
Why do we need lists?
Because we just need lists for plots. We just need lists. We need a list to plot everything.
Thank you. Because when it comes to plotting, we need a list for x values and a list for y values. Initially, we are creating 2 empty lists. One for x, one for y. I'm naming them xxx and yyyy. You don't have to do that. You can name them whatever you want, as long as you know what you're doing. Then I'm creating a counter that counts from 0 to 10, which basically will give me 9 steps. And then I am saying that for every value of I want you to multiply 1 by the value of I and add that to my x list. So when I is equal to 0, what am I adding to my x list?
You're adding I, like 1 times whatever I is.
Yes, so if I is 0, I'm adding 0. If I is 1, I'm adding 1, and so on. Also, I want the value of my x, which I have defined very much equal to I, to be taken to the power of 2 and be added to my list of y. I actually don't need this. So, for every value of I, I'm saying add 1 multiplied by I to my x list, and x to the power of 2 to my y list. And then I'm calling the plot a line function, and I'm feeding the x list as the first input, the y list as the second input, x as the title of my x-axis, y as the title of my y-axis, and plot of y equal to x to the power of 2 as the title of my plot. And that's what I will get. Does that make sense? Pop-up question. Which part of this whole plotting section is more important to me in this evening?
Probably the list part.
Thank you very much. So I beg you to keep this in mind, that you need to give lists to get lines. If you only want to get 1 point, that is okay. You can give 1 value for x and 1 value for y, and it will give you 1 tiny beautiful point. But if you want a line, if you want a curve, you need multiple x values as a list, multiple y values as a list, and then it will go and connect this for you. So, we are at the end of lab 5. Let me know if you have any questions in this notebook.
Yeah, okay. That was fine.
The labs you've graded, how do we know what we missed?
Come again?
Like for the labs, if we got like a point off on this lab, how do we know what part we messed up on?
So every time, even if you get a full mark on your grade and you have a question, you can email me or you can come to my office hours and we will go over your documents. If you want to discuss your notebooks in private, you can also email me and we can set up private Zoom links for that.
Okay, thanks.
Yeah. By the way, I do remember why you're asking that question. So if you are wondering, you can let me know. So, do we have any other questions on this notebook?
Are all lab 5s graded yet? Because I don't see mine on my
it is in process. So some of them are graded, some of them are not.
Okay, yeah, because I wanted to see if I did everything right, because I think lab 5 is really important, in my opinion. So I want to know if I did anything wrong. So wait for the exam. I'm trying to get them to you as fast as I can. But if you have a question and if you want to make sure about something before the midterm, feel free to contact me, and do not wait, because it may not be prepared before the midterm. Okay, thank you.
Yeah. So, do we have any questions on this notebook?
Yes.
Yeah.
I wanted to ask, why does the plot align function have to be in the same block of code as the defining factors? Because I tried to do it where it's not, and then it just said plot align is not defined. So I moved it into the same block of code, and then it finally worked.
Well, the thing is not about it being in the same block of code. The thing is that it needs to be run before you call it. So,
okay.
Plot align function is a user-built function. It's something that we defined. So, in the primitive Python, in the initial format of the Python that you run, there's no function called plot align. And if you call that function without defining it, Python will be like, I really don't know what you're talking about. So you first need to go, okay, Python, listen to me. Whenever I say plot align, I want you to ask for 5 inputs and do these with these 5 inputs. Done. Then you can go ahead and call plot align function and Python will understand what you're saying.
Okay, thank you. Yeah, I guess I must not have run it before. So
yes, that is something that many of us have the habit of. So when we want one specific cell, we just go to that cell and run it, and that will cause lots of errors because usually you only import your external libraries at the top of your notebook, or you call a function or you define a function in a separate cell, and that will cause some issues. But that's okay. So, any other questions on Lab 5? Okay, I'm moving on to Lab 6, the first part of Lab 6, which is on classes. Lab 6 basically had two parts. One of them was on classes, the other one was on file manipulation. In terms of classes, what we taught you is that you can define a class with certain attributes, and then within that class you can create an infinite number of instances. So, for example, we talked about my office example, which would ask you to basically create a class and name it personnel, and then ask for different attributes of your employees, in this example, first name, last name, and age, and then generate email addresses for them with the format of firstname.lastname@DunderMifflinPaperCompany.com. That was one part of it. Then we used that as a base for our next question, which was, okay, now go ahead and add a method to your class and calculate the year each one of these employees were born in. So, pop-up question number 1 for this lab. What is a method?
it just takes a set of inputs and then does something with them, right? That's.
You're getting very close. Let me.
Or like it returns a value.
So, a method is basically a function that you define within your class. And the way that you define it is actually very, very similar to the way that you define a function. So, let's see, for example, at this example, starting from here, what we have. We are defining a class named personnel. That is the syntax. You go with class space, the name of the class, and then a column. Then you go with define. This is called the init method. And then in the parentheses, you use self. You can use any other word, but self is just a convention, and it is generally recommended that you go with that convention. And then after self, you start defining the attributes that you want for each instance of your class. So for this example, we had first name, we had last name, and we had age. So you name them here, and then right below you say, okay, I want this input to be attributed to my self entry as first, last as last, age as age. And then I want another attribute for myself, which is equal to whatever was in the first, plus a dot, plus whatever was in the last, plus this string. And that is the line that we are using to generate the email address in the format that we wanted. We are also going to add a method or a function to our class. I'm going to name that function full name. You can name that whatever you want. And I want that method or function to be run on self or on each entry or on each instance. And what do I want from that? I wanted to go in and use this format, put the first name of that entry in the first place and the last name of that entry in the second place, and then put one space in between them. Okay? Then I will just go to my next line and start from the beginning, which means that this block is over, and in this block I'm defining my class. Then I go and create my instances. I'm naming the first one EMP_1, and how I define it is that I basically call my class, which I named personnel, and then in parentheses I give in the attributes. Which attributes? These three. First, last, age. In what order?
You'll call it first, last, then age.
Exactly. So in the same order that I gave it and I defined it. So you need to understand that when we talk about the smart machines, it doesn't really mean that the machines are smart. It's the programmer that's smart. So if I go in and define an instance and say, instead of Michael Scott 43, I say 43 Michael Scott, and if I expect that Python will go and say, okay, 43 is a number, and that can't be a first name, that should be the age, that's not going to happen. Python is going to assume that 43 is the first name, Michael is the last name, and Scott is the age. So you need to be consistent with the order. Very similar to what we discussed about user-built functions. So this is how I'm creating my instances. Input 1, input 2, input 3, first, last, age. And then once I do that, I can go and call different attributes by themselves, or I can run the functions or methods built into my class on these instances. For example, what is happening here is basically me calling the personnel class, calling the full name method that I have defined within my personnel class on this specific instance, which I've named EMP_4. And the output of this will be Dwight Schrute. So, before I move on, I want you to tell me if you have any questions about classes, how we define them, and how we use them.
I have like a small question about like all the definition classes.
Mm-hmm.
Like, is there like a comprehensive list at where I can find like, hey, this is what can be used in class and def? So, like,
well, you can always use Google.
Yeah. Okay.
And it will give you pretty good info. So let's say Python class definition. I hate you. Python class definition. So beginning from the top, you will find lots of different resources, weblogs, forums, and it really, at least in my view, it really depends on what you prefer. I usually like weblogs rather than very formal documentations.
Go to the python.org one, and you can explain why you like weblog in a second.
Sure.
Literally.
So this is the official document from the python.org. And you see that it starts explaining everything in a very, very formal way with an introduction, and then all these details, but in text. So you basically have to read all this.
And it's essentially useless. But if you go to a weblog, even the examples are useless.
Let's see what we have here. Probably this one. Oh, this is something I really like. Geeks4geeks. But let's see what we have. So this is the Geeks4geeks.org, and you see that they start jumping to examples pretty fast, and then they have all these like figures, tables, and examples. I always find these more easy to communicate with. The other one that I opened is from digitalocean.com. I have actually never been to this one, but this also looks like
that's
a weblog.
That's a good blog.
So yeah, I recommend that if you have questions like that, or if you're just curious about something, go with this format.
Okay.
Python and your question, or simply Python, how do I, and then the rest of your question. Define a class. And then, again, lots of lists will come up. Something that both Dr. Cleveland and I want you to take away from this class as a long-term tool is how to use Google and online resources for coding. Because there is no way that any course or any book or any instructor can teach you everything about a programming language. But when you have Google by your side, and if you know how to use it to your benefit, you will be very, very powerful. So, let me close these. Oops. Share. Sorry. So, going back to our notebook, I will ask again, do you have any questions about classes, their definition, and their use? No. Okay, let me check something with Dr. Cleveland. Dr. Cleveland, would it be okay if we go for a little past 7?
Sure.
And for the students, if you want to stay, we are running probably a little later than 7, but if you want to leave, you can leave anytime you want. So, moving to, Lab 6, files. In this notebook, we basically talked about how we can create or write a file, how we can read a file that already exists, how we can update a file that already exists, and all that. So, I'm going to tickle your memories a little bit and ask another pop question. What are the 3 fundamental steps in file manipulation?
As in, like, the A, R, and W?
You're getting close, but I would say those are the 3 things that you can do to a file.
Open,
but there are,
close, and create.
Go again?
Open, close, and create.
You're getting very close. So this is something that I told you when I was going over this, but I'm not sure if it's written in there somewhere. So there are 3 main steps. The first one is to make a connection. The second one is to do whatever you want to do, which includes the 3 steps that Max told us: writing, reading, updating, or appending. And then the third step is to break the connection. These 3 should be there when you want to work on a file, on an external file. Make the connection, do whatever you want to do, break the connection. So, what we worked on was to first checking the path to our working directory. If you are working on CoCalc like me, this will be what you get, because CoCalc only has one directory that you can work in, and then some very useful commands that will help you get a list of all the files that you have in your working directory. Then we started with creating the file. For creating a file, we use this syntax. Open parentheses, the name of the file that you want to create. In this case, it's myfirstfile.txt, comma, W. What does this W stand for? Right. Thank you. So, in this line, I'm basically creating a new text file, naming that myfirstfile.txt, and storing that or assigning that to an object called external file. Then I am creating a string that can be anything that you want. In this case, it's message in a bottle. I'm storing that string in another object that I call my message. Then I'm using the .write function on my external file object. And what am I writing in it?
Message in a bottle.
Exactly. The contents of my message object, which is message in a bottle. And then what am I doing at the end?
Closing it.
I'm closing it, or I'm breaking the connection. So, 3 main steps. The first one, create the connection. The second one, do whatever you want to do. The third one, close the connection. Does that make sense? I hope so. So, then we talked about the icat function, which basically reads the content of a text file for you. And then we talked about reading an existing file. Can you tell me what is the difference between this line and what I had before?
You can't add to it, or the writing is
very good. But looking at the syntax, what change do you notice?
The R instead of W.
Thank you very much. So instead of W, we have R, which stands for read. And we use this whenever we want to read a text file that already exists. In the previous step, we created a file that didn't exist. So we know the name of the file. We just read it. So again, in the first line, we are creating the connection. Then we are storing the content of that text file into an object that we are calling silly underline string. We are closing the connection, and then we are printing that silly underline string. So again, you can see the 3 steps. Opening or creating the connection, doing whatever we want to do, and then closing or breaking the connection. Make sense? Cool. Then we talked about updating the file. What is the difference between this one and the previous ones?
We have way more code.
Yeah, but the first line has A instead of W or R, which stands for not updating, but append. Yes, so we use this whenever we want to go and open a file that probably exists there, but not have to, like read. And then we want to change the content of that. So here you can see that in the first line, I'm creating that connection. Then I basically starting from here until here, I'm just creating the strings and adding those strings to my text file. Now that string can be simply /n, \n, which means next line, or another string or a sequence of number, whatever that you want to add to your text file, and then we close it. So this same essential steps you can see here. Open, do whatever you want to do, close. And then we talked about how we can delete a file. We talked about 2 different ways. The outcome will be the same, and they're going to remove the file that you want from your working directory. The examples and exercises for this were so easy that I'm not going to even talk about them. but this is the time that I will ask if you have any questions about this notebook.
So just to make sure that append is to add to what's already on the file, and write is to, so for write, it just kind of deletes everything and then writes what you want. Is that what I'm?
For write, if you have a file in your working directory with that name, it is just gonna overwrite it. So I don't know if you are interested in gaming, but what happens in gaming is that if you do a save on top of a file that already exists, it will overwrite it. So it will assume that from this moment on, you only have the latest version. The previous version is gone. But with read, you can only read. You cannot change the file. And with append, you do not delete the previous version. You can just go in and do updates on it. You can add text, numbers, whatever you want to do to it. Any other questions on this notebook? No? Berlin. Is the exam just overlaps 1 to 6 or is it overlaps 1 to 8? I'm going to check with Dr. Cleveland, so make sure that you ask that question again. But I think even the lab that you will have on Tuesday is part of the midterm. Yeah. Yeah, you're welcome. I'm sorry if that was not considered as the best news, but don't worry about it. You have it. Oh, Dr. Cleveland is here. So, Dr. Cleveland, they're asking if the labs from 1 to 8 will be included for the exam, and I told them that probably what we're going to work on Tuesday is also included. Am I right?
Yes, because Tuesday's map plot library.
And you have already worked
I mean, we've already exposed you to it, but we'll go into some more of the features of that library. We could do an entire month on map plot library. We're not going to. We'll do one day.
So I hope that was a good clarification on questions about the content of the exam. Let us move to Lab 7, or NumPy. So, both this one and the next one, so NumPy and Pandas, they are on external libraries. In terms of similarities, in both of these notebooks, we are talking about a variety of different functions and options that these libraries give you. Another similarity would be that the building block of NumPy is arrays, and the building block of Panda is
bears.
Data frames. So with NumPy, we keep talking about arrays of 1 dimension, n dimension, 3x4 arrays, 5x5 arrays. In Panda, we keep talking about different data frames, rows, columns, content. And what you need to keep in mind is that Panda kind of comes on top of NumPy. And that's why whenever you want to work with Pandas, you need to import NumPy as well. So let us go and see what we have covered in the NumPy notebook. I may be going a little faster, but please make me stop whenever you have a question. So we talked about different arrays, the difference between lists and arrays, how we can define n by n arrays, 2x2, 2x3, 3x4. The first number is always the rows, and the second number is always the number of columns. Then we talked about slicing arrays. We talked about running simple operations on arrays, adding them up, multiplying them, summing them, finding the maximum, finding the minimum. So these are all different but very common and useful syntax in association with the NumPy package. The argmin, the min, the argmax, the power function, all of these. And then same, talking about operations and applying operations on n-dimensional arrays. We had examples. We talked about comparison of arrays and how they work. So they basically go in an element-wise approach. First element in the first row and the first column of array A will be compared with the first element in the first row and the first column of array B, and whether it's greater, it's less, depending on what you want to compare, the answer will be a true or false. So we are talking about Boolean objects again. Esteban, I don't know what that means. Is that a good thing or a bad thing? I can read that hat, 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 but I don't know if that's a good thing or a bad thing. You want to elaborate?
Referring to the previous.
I meant on the question that's on top. Like, is it the exam over 1 through 8? I mean, 1 through 6 or 1 through 8 of the labs?
Oh yes, Dr. Cleveland already answered that question. It's going to be everything from the very first session up until the end of the session that we're going to have on Tuesday. So actually until the end of Lab 9.
Okay. Amazing.
Yeah.
Thank you.
So then we talked about array manipulation, how we can create a copy of an array, how we can delete certain parts of an array, columns or rows. Then we talked about sorting arrays, which is extremely important. You can, okay, let me ask a question here. How can I sort an array of strings?
You can sort them alphabetically.
Okay. Let's say I have an array of 4 rows by 3 columns. If I want to sort this array alphabetically, will this be sorted by rows or by columns?
It'll be sorted by both unless you specify like the axis.
Yeah.
You're getting very close. So if I specify by the axis, then it will be sorted depending on what I want, by column or by row. But you said something that had me a little confused. How can you sort it by both?
Oh, I just meant like it wouldn't pick like for you. Like.
Thank you very much.
Yeah.
So something important that you need to realize is that I have actually talked about it here. If you want your arrays to be sorted by axis equal to 0, it will sort them with respect to the columns in each column. If you say axis equal to 1, it will sort them in rows. If you do not say anything, it will still sort them in rows. So that is like a default assumption of Python.
Okay, gotcha.
And something else is that if you choose none for axis, it will report or print out a structureless format of the array. So just simply as a list, everything following each other, like this. Talking sorting arrays, we talked about slicing arrays. If you want to separate one row or one column or one element or a piece of the array. So let's say you have a 5 by 5 array and you want to separate out a 2 by 3 array from that. We talked about all those. and how you can do that. And if completing the notebook, you had 6 exercises to work on. Let me know if you have any questions about any part of Lab 7 and the NumPy library. Please ask a question, because if you don't, that is a very scary sign.
So in exercise 6 of this lab, we had to, like, so eventually you had to sort it by, I think, columns if you wanted it to print out in a particular way. But
exactly.
I feel like you had to actually, like, look at it and understand where the locations of the names were. Like, I don't know, I feel like you had to, like, figure it out in your own head before you could determine whether you're sorting it by rows or columns. So, like, am I right? Like, there wasn't any way other than your own, like, determination. Like, I mean, you couldn't, like, do it any other way than that, right?
Well, the idea is that when you are given a list like this and you are asked to put that into an array of 3 by 4, you are looking at 3 rows and 4 columns. And you just start filling them in the common way of English language. And then the second part of the one thing that you need to realize is that these parts come right after each other. You cannot jump from A to C. Yeah, that wouldn't make any sense. So after part A, you will sort the array that you have created with respect to each column. And when you do that, you will have them sorted alphabetically because you're dealing with an array of strings. And then in the last part, you need to go and look at this sorted array and find a 2 by 2 array with these names in it. And once you find that, you will go with the right index to slice that out. I'm not sure if that was a good enough explanation.
No, yeah, that makes sense.
Okay, cool. Any other questions about this lab? Then let's move to Lab 8 and Pandas. So, touching on this again, the building block in Pandas are data frames. What are the 3 essential components of a data frame?
I want to say columns and rows are just like the 2 most important things of a data frame.
The third one?
Yeah, I don't know, dude.
I bet you do. So let's have a look at
values within the data frames.
Exactly, or what we call contents. Okay. So 3 essential parts of a data frame. How many rows? How many columns? And what is the content?
Okay.
So that is actually what you need to define a data frame in Pandas. In this notebook, we talk about 3 ways that you can go with to very easily create a data frame in Panda. And then we talk about different functions built in the Pandas library that you can use to get information about an existing data frame. What is the shape of that data frame? How you can add a new column to a data frame, how you can add a new row to a data frame. I cannot emphasize more on how important each section of all these notebooks are. So once again, make sure that you read the entire body of your notebooks, all of them, all 9 of them, before coming to the midterm exam. Then we talked about how we can remove a column or a row from our data frame. We talked about indexing, how we can go and select a specific part of a data frame, whether it's only one element or an entire column, an entire row, or a combination of rows and columns. We talked about conditional selection. We talked about descriptor functions. As I told you, these can be extremely useful for engineering purposes. whenever you have to deal with the statistics. We talked about the head function, the info function, the describe function. We talked about counting and summing methods. We talked about unique values and what they mean. Pop-up question. What do we mean by a unique value in a data frame?
Only appears once.
Yeah.
Thank you very much. So if I have a column that consists of 2, 5, 5, 7, how many unique values do I have? Thank you very much. 3.
Oh, wait, 3.
3. Because even we have 5 twice, but we will count it as a unique value once.
Okay.
So just because the number is repeated doesn't mean that it's not unique at all. It's unique only once.
Gotcha.
So, counting and sum. Then another vital aspect of the Pandas library, the symbolic apply, or basically applying a function on the entire data frame, on every element of the data frame. And we have used an example to illustrate how that works. We talked about sorting, again, similar to what you have learned in the Numpy library. We talked about grouping data frame contents, especially when you have similar keys within your data frame and you want to do like one specific operation on everything that has that mutual key or mutual aspect. Then we talked about another important thing, which was dealing with missing values. So if you have a data frame and you have entries in that data frame with no values, there are certain things that you can do. One of them is to delete every row that has a missing value. That will cost you so much data. One other way is to go in and replace every missing value with a 0, or replace every missing value with the average of that column. And these are all useful depending on what you ultimately want to do with your data frame. But this is something that we have worked on. Then we talked about reading and writing data frames as files. So we can have data frames in formats of a CSV file. We can have them as XLSX files, or basically Excel files, and also JSON. What you need to keep in mind is that depending on if you want to work on a CSV file or an Excel file, you are using different functions. So in this one, we are using the read underline CSV function from the Pandas library. And in this one, we are using the read underline Excel function from the Pandas library. The syntax are pretty much the same, except for this one that since you can't have multiple sheets in an Excel file, you can go and say, okay, I want this specific sheet of this Excel file. But other than that, the syntax is very similar. And then, since you can read a CSV or an Excel file, you can easily write a CSV. And here you will see how to do that. And then you were given one exercise in which you had to read an external Excel file and do some work on that. I'm not going to show you the answer to that, since that is still in progress. So I want you to have a look at this notebook, Lab 8, and tell me if you have any questions about it.
I guess I have a small question.
Go ahead.
For exercise 3, it said rename the rows, and I actually found like a Pandas script method, I guess you would call it. I don't know what it's specifically called.
You can call it a Panda function. That's okay.
Okay, a Panda function, and it literally would just rename it by just inserting a new list. Is that okay?
Brandon, not just for this, but for this entire class, I can tell you from my own perspective. Dr. Cleveland is here, and he can tell me if I'm wrong or right. As long as you are doing what you are supposed to do, I don't really care what method or function you use. You can define your own function that will give you something that you want, or you can use a function from an external library, or you can use a function that is built into Python. That is your call.
What happens, just as long as I can tell.
No, actually, in fact, when I'm looking at your lab assignments and I see a student who has done something creative and new, I enjoy it.
There.
Because you are going to become an engineer. Your creativity is something that should be encouraged, not limited. So there are many things that you can do using a function in math or using a function in NumPy. The output is the same, so why would I care which one you want to use? If you prefer to use something from math, go ahead and use it. If you prefer to use something from NumPy, go ahead and use it. The only thing that I would say and add to this is that when you are using a function that you find somewhere, make sure that it is doing exactly what you want it to do, and not just for one case. Because you may find something, bring it to your code, run it, and it works perfectly if you try it with number 0.
Yeah.
But if you try it with number 5, that will not do what you want it to do, and that's bad.
There.
So you're free to use whatever you want to use as long as you are meeting the requirements of the problem.
Sweet deal.
Esteban, what exercise?
That's checking right now, training and writing to XLSX file. I don't know if it's irrelevant right now because we're studying for a midterm. But I can wait to ask you the question after or something.
Okay, yeah, we can do that.
Okay, I'll wait then.
So, any questions on Lab 8?
I'm also going to need help with an exercise.
Okay, can you guys actually come to my office hour meeting tomorrow morning?
What time is it? Because the job fair starts at 10.
Oh, that will be from 9 to 10.
Okay, perfect. I'll be there then. That's fine.
So, I didn't see who asked the second question.
Oh, I asked.
So, can you come to the office hour tomorrow morning?
I think I can.
Okay, wonderful. So, we will have 1 hour to work on any potential issues that you may have, and we can go over that. About the midterm, about the 8th notebook, about the 8 notebooks that we covered. Do you have any questions? So, before I close this meeting, I want to once again emphasize that, first of all, I believe if you know the material in the notebooks, and if you know your way around them, you should not have any difficulties in acing the midterm. The second thing is that I think it would be very smart of you to make sure that you know everything that is in every notebook that we have covered. Text, example, exercise. I think this is probably the 10th time that I repeated that. So you should get a feeling of how important that is. And the last thing, study for your midterm. Do not leave it for the last minute. I have office hours on Monday and Wednesday from 9 to 10. We are going to meet online on Tuesday, and I usually hold a brief meeting right after the lab. So today we are meeting tomorrow, Tuesday, Wednesday. If you have questions, you can come to the meetings and ask those. If you can't make it to those meetings, email me and I will try to reply to those as soon as I can. And I believe you have all the resources that you need to ace this midterm. That's all I have to say. Dr. Cleveland, is there anything that you want to add?
I have nothing to add on both the in-class and take-home when you get to it, so don't be scared. Read the questions before you try to answer them. Read the entire questions. Yes. And that's it. That's
I can't agree more with that. Thank you very much for coming to the meeting today.
Hey, Farhan?
Yes?
How many quizzes have we taken? Because I know we've taken up to Lab 5 quiz, but I don't know if I've seen a Lab 6 quiz.
I think you have taken 5 quizzes. There was an issue with quiz 6, which I have emailed Dr. Cleveland about.
Quiz 6 has disappeared for the time being, so don't worry about it.
Okay, so you have taken 5 quizzes,
5 quizzes, yeah.
So far.
Is the exam going to be like scattered around, or is it gonna like follow like our lab 1, 2, 3? Like, does it go in order, or is it gonna be on random?
It's not
random, I would say.
It's not ordered.
Okay, okay. Thank you.
Any other questions? Okay. So thank you again, Dr. Cleveland, for giving us your time this evening. And be safe, take care, study hard, and enjoy the rest of your Sunday night.
We could do a bonus question. How many cats did you see in the video tonight?
Yes.
How many different
3
cats? Good.
He only has 2 cats. I thought he has them.
No, I have 3. You saw 3 cats tonight.
Dang.
But the dark one, you only see a flash because she doesn't get out and very much. Okay, well, I'm going to shut off. Well, wait, I'm not in control of the call, so whenever you're ready to shut it down, I'll stop the video.
Sure. I will. Take care, everyone. Be safe and let me know if you have any questions.
Thank
Bye.
You.
Bye-bye.